Folks, thank you all very much for joining us. We're here for the 5th session on the Industrial Metaverse World IoT Day. Now, my name is Kevin O'Donovan. I'm your host. And just before we begin, some very quick housekeeping. Those of you who have been online heard Lucian talking about, one of the values of IIoT World Days is that they're live and they allow us all to interact in real time. In the previous sessions, we've had over a couple of hundred people, 300 or 400 people live. You will see on your screen a chat box on the right-hand side. That's where you can interact with all of the other attendees. And if I may, type in there, tell us where you're joining us from today, because there's people coming in from all time zones all across the world. As Lucian mentioned, in order to keep this as interactive as possible, please do ask your questions. Looking at the other 4 sessions today, there's no shortage of questions. Under the video on your screen, you'll see a Q&A button. Click there, ask your questions in the Q&A there. If you ask them in the chat, we personally won't see them in the session here. So in the questions in the Q&A. And we should be done in about 50 minutes or so. And obviously all of today and the sessions would not be possible without our sponsors. So a shout out to GE Digital, to Intel, Hitachi Vantara, Orsoleo, Siemens, and Darkpulse, and obviously specifically to Intel for who are sponsoring this session. So for this session, we're here, pervasive compute everywhere, industrial metaverse at the edge and in the cloud. And I'm delighted to be joined by Ricky Watts, the Senior Director of Industrial Solutions from Intel, and Lynn Neese, the HP Fellow and CTO for IoT from Hewlett-Packard Enterprise. So before we get started, we're going to run this as a panel. So I have a couple of questions to ask the folks here in terms of their thoughts on the industrial metaverse. But before we kick off, let's do quick introductions. So Ricky, if I may, for folks that may not know you, could you do a quick introduction?
Sure can, Kevin. So thanks for that. Mentioned Ricky Watts. I am here over at Intel. I am in the Federal and Industrial Business Unit. I look after what we call segment markets in Intel. Basically, that is really how do Intel technologies get applied into the industrial environments, industrial customers. So I look at all such things as control systems, operational systems, compute systems that exist in the industrial domains, and what are our customers trying to do in terms of the outcomes that they're driving with those industrial systems. So that's kind of my role in Intel. I look at the entire portfolio of Intel products and how we can apply those into those market segments, and a great opportunity to talk to you today on a very interesting subject. I'll leave it at that.
Thank you, Ricky. And it certainly is an interesting topic.
Yeah.
Lynn, welcome, sir. And if I may, a quick introduction from yourself.
Sure. Thank you so much, Kevin. So I'm Lynn Neese. I'm an HPE fellow. I'm in our advisory and professional services business, and we have found ourselves compelled more and more, as I'm sure everyone is aware, HPE is mostly a technology vendor. An IT technology vendor. And we have found ourselves compelled ever more into this world of what we'll call the border between IT and OT, because so many of the projects we're talking about, including today's topic, require networking and processes and hosting platforms and the like that are just so commonly found in IT. And I spend a lot of my time, for example, directly with customers, in addition to helping drive new offerings from our company.
Thank you, Lynn. Now, I suppose one of the fascinating things in the session today, and Ricky, you mentioned it in your opening in terms of it's an intriguing topic. So let me jump straight in with the $10 billion, or I don't know, about a couple of $100 billion question. So Ricky, what is the metaverse and why is it important?
Well, yeah, I suppose it's the $1 million question, Kevin, really. I'm going to approach this in 2 ways, I suppose. We often think of the metaverse, and we obviously think of the, Facebook and their movement towards meta, and this idea of creating what we call digital environments in a way that you could get into those digital environments, create immersion through those digital environments. So that's one aspect of it, that I suppose that we see maybe on a day-to-day basis. On the industrial world, which is really, I think, where we see this crossover to the metaverse. So in industrial, we've been using data and digital data for a long time. So really, for us, when I think of the metaverse, it's how can I take what we've been traditionally doing in industrial environments and extract them in a way that I can then connect them to people. So, one of the problems that we have, in industrial is, we're asking customers to drive outcomes based upon data. But, a lot of the customers we work with, they're industrial customers. They don't, how do you get into that environment? So to me, when I think of the metaverse and I think of what it is for an industrial, it's really bringing those shared environments together, those digital environments together. And then how can I present myself in that digital environment so that I can create that immersive experience to understand better that data, how it's applied and what it means. So it's really, to me, it's about connecting people with data, that immersive experience. I mean, and I think that answers maybe the second question is, why is it so important? And I said, I was talking yesterday to somebody, we have data telling us so many things. Data says turn the button right or the knob right. Data says turn the button left. Data says don't move the button. And then data says, why do I need the button? So how do people that are interacting in an industrial environment, how do they better understand this? So to me, why it's so important is you've got to be able to connect the way that we represent the data, the idea of what the metaverse offers, with the way that create an immersive experience is make it real to people. So bring them into that environment, allow them to experience that data in a way that's natural for that person. They can share those experiences. Not only can they see the data, but they can share that in a different way so that as they start to understand that digital environment, how are they going to apply that? So that's why I think it's important, because I think it transforms from where we are today, which is a two-dimensional digital world, and then moving it into a way that I can actually express myself or be involved in that data in a very different environment. So, it's a very interesting crossover point. And I'd say, we're on a journey with the metaverse. I'm sure we'll get to that question later. And Lynn's probably got some responses to that as well.
Lynn, from your point of view.
Yeah, great points, Ricky. And I would say, to me, what I find extremely interesting about the industrial metaverse is it's a celebration of the value of people and the role that they play and will continue to play in processes. What use is there for immersive experiences and for collaboration if people are not a stressed member of your operation? I mean, truth be told, with all the discussion we've had, we all know this goes back hundreds of years. This is not new. The concept of automation, the concept of mechanization, the role of people, the value of people, we're getting automated out, the glass cockpit. Folks, the metaverse is truly an indication that, the value of these use cases we're going to talk about, everything from digital twins to remote control, is all about exploiting people's value in a reliably futuristic way. People aren't going away, and the role people play in our business is not going away. The metaverse is an acknowledgement of that, and hopefully the manifestation of making people more productive and even more valuable. And that's why I think it's important.
Yeah, I agree.
No, good points. And if I may, I suppose, Ricky, you mentioned in terms of it's about connecting people with the data, and depending on how far out we look, we talk about, the metaverse, and it'll be a 3D spatial digital representation of physical assets. We'll be able to simulate lots of stuff. It'll be persistent. So if I go home and go to sleep, when I come back in the morning, it's continued on, and you've been in and out, and there'll be an economy and whatever, right? So the art of the possible is fascinating. But I suppose to make it a bit more tangible, do you have any examples of where you see this stuff, people and data coming together today, like, the baby steps to get us to wherever we're headed?
Yeah, no, and I think that's really important, Ken, as well. I mean, as we sort of stand here at the end of 2022, who'd have thought the world has changed so much, maybe even in the last 6 to 9 months? We've got inflation issues going on, a lot of world challenges, and how do I relate that to your question, which is, where do we start and what do we do? So look, Lynn mentioned digital twins. in industrial, which I've been working in for a long time now, the concept of using data is not new. I mean, the concept of understanding data and using that data to drive an outcome is not new. So that's predominantly been done what I call in a two-dimensional environment. You get the data out, you look at the data and you analyze it. It used to be done in spreadsheets in this thing called Excel, so, and we used to use Excel. So, and now we're starting to get much better tools, of course, and we're now moving into this idea of AI, artificial intelligence, which is probably to some extent with the compute environment is the backbone of really what's going to drive the metaverse. So I would say where we're at today is we're already starting to use data. We're using it collectively to drive things in manufacturing environments. And, personally, I'm involved in such things. And we made this announcement recently around companies like Audi using data to drive better outcomes in terms of manufacturing and things like that. So we're already using that. I think the step over to the metaverse is, as I say, what I've seen is this idea that the world just becomes data only and it all becomes kind of like Cyberdyne systems and it's all like a game. That isn't the case. Lynn mentioned it. It's about people. People are not going away. And we don't want people to go away. What we want to do is create an experience where people can understand and use that data and bring their own collective experience and share that collective experience. I often hear, when I'm in manufacturing, people, they're saying, hey, I wish I could create a digital twin of Harry over there because he knows my environment really well. So you want Harry to be involved and sharing his collective experience. What he does at the moment is he does that in a two-dimensional world. So we are using digital twins. We are using data. We are using compute to drive outcomes already, whether it's improving outcomes in factory, defect detection, some of the obvious things out there as well. I think what we're starting to see now is some of the barriers of that data around how does that work with the people? And I think that's where the metaverse offers. So for me right now, I think, I've been using data for 20 years. So nothing new here. This is just the next evolution of that. And I thought one of the biggest challenges was that we were leaving the people behind for the sake of the data. And I think that's been a problem that I've been seeing. So as I said, look, now we've got to get that back. We've got to get balance back between the experiences, the skills, the emotions that come in with the strength of the data and using AI. And I think that's where we're at today. So it's a little bit, let's peel back. Let's start to see where can we drive these things next. Let's look at the models that we got, expanding digital twins and things like that. So to me, that's where we're at today, Kevin. We've got to be very realistic of the environment we're in today, what's going on out there, using the compute systems that are going out there, and then start to introduce the more future views of what the metaverse is going to offer as we start going into a next generation of system.
No, good point. And Lynn, just before I come to you, for folks that know me, I was in Compaq, HP, Intel, spent most of my career in the IT enterprise world. And as we brought out new technologies, be it Wi-Fi or cloud or AI, whatever, we always kept, we're going to get rid of all the people. And to be quite honest, we haven't. And Lynn, to your point, it's all about people.
It is.
And again, I suppose some of the examples you're seeing in your world today.
We have great examples. So the U.S. Department of Defense actually trains sailors. Thousands of sailors are headed for a particular type of ship. And to train them on where they're going to find the different operational control surfaces, where to navigate, wayfind, how their operating role will be done, right? You can actually train people on a digital twin. And the ability to train people on a digital twin of a destroyer vessel, we're talking hundreds, if not thousands of sailors, is a huge, huge benefit. It's so capital intensive to have them have to learn on the job in the physical environment, things they could be learning using immersive technologies and digital twins. So, and I think this gets back to that first question we saw from Samir about dividing. For the industrial metaverse, there's no separation. In fact, the challenge for us is that the value of the industrial metaverse is to synchronize the physical and the virtual worlds and to create simulated what ifs. Yeah. So these use cases, though, another use case we're seeing emerge is the use of expertise remote. see what I see. Very simple. It's something you might be able to do with FaceTime, but arguably much more valuable if done immersively and with annotation capabilities and other heads-up capabilities to take people's expertise and to be able to distribute them to remote locations without having them board an aircraft and burn tons of carbon, create tons of carbon, or be in 3 places at one time. Those are all great benefits that we're seeing right now today of the industrial metaverse. And we're seeing safety, a great benefit. There are cases today where people are operating equipment remotely that an operator used to have to be inside. So imagine a wrecking ball knocking down a building and the person there moving the levers of this machine to control the destruction, basically. I don't have to do that sitting right next to this collapsing building. I can do that from a room far away. These are examples where we're seeing this metaverse capability coming about right now, but they do require a synchronization of sorts between the physical and the virtual world. That belies a little bit of the history of how these 3D environments have arisen.
Yeah.
Oh, no, good point. And Ricky, I know when we spoke in preparation for this, you mentioned as well that, it's not the digital world and the physical world diverge, right?
Yeah, they are coming together. I mean, Lynn gave some great examples, and you can add to that. AR, VR, those types of experience that we see predominantly, in a gaming environment, but we are starting to see that pop up. I kind of go back to what you started off. We're in a very different world. I call it after COVID. I mean, we went from a world that was kind of like fully running around on airplanes, jumping in, and everybody was on site doing things, to a world where everybody was effectively on a 2-dimensional screen like we are today. So our world's changed, and the use of technology in that environment is changing as well. One of the big challenges for a lot of the industrial customers right now is workforce. How do you manage a workforce that is largely doing a lot of turnover? So they're changing workforce because we had this kind of great resignation. Things are changing a little bit now, but there's certainly a lot of turnover. Lynn mentioned training. Training becomes a very important part of that. But collectively, I can't create a control systems engineer in 2 months. It's impossible. But what I can do with this type of environment is allow that control systems engineer to be in many more places at once, or training many more people to do that type of work. So it helps with issues around workforce management that we see today. And again, these are kind of tactical things that we're doing today that in a sense all lean back to that collective idea of what the metaverse is. So what are we doing? We're using technology today, digital twins to drive outcomes, different ways of people interacting. We're now creating ways that they can not only interact, but they can be in 2 places at once. Effectively, somebody else's pair of hands is now doing something that you're enacting. And we see that in the healthcare industry and in the industrial environment. So this technology is there. It's being used tactically to drive different things right now to help industrial customers solve problems, training, remote workers, etc. I think what we're starting then to see is, how do you bring this collectively together to make it even more powerful? And I think that's probably where we start to see maybe what a lot of people think of as the metaverse, when they kind of like think at a very abstraction layer that, everybody lives in a 3D virtual world. We effectively, we go to work in the morning, with our avatar on, and the world is basically virtualized. That's kind of like one extreme to the other. But, what we're already doing is using technology today to help our industrial customers. That technology then just becomes part of that movement.
No, great points. And if I may, you often see a lot of stuff in the press, and people say metaverse and they equal it with meta, right? And they go, oh, well, we've seen what they're doing and whatever. But you look at what the likes of Microsoft are doing, right? So we're here on, whether it's Zoom, MS Teams, they're all adding on collaborative environments, Altspace VR that Microsoft own. They own gaming engines for the simulation. You look at what Siemens are doing, what you guys are doing, and. Now, if I may, where I see one of the fundamental building blocks for whatever the metaverse ends up to be is the digital twin. Okay. So if I may, Lynn, where do you see How do you define a digital twin, and where do you see it fitting into the future?
Yeah, this has always been one of those tough areas for us and our customers, because we have customers who believe they need a digital twin for some capability, and what they really need is something that they could have been doing for the past 20 years. You could argue that your online banking app on your phone is a digital twin of your account, right? But I mean, that's an extreme example. What we tend to think of as a digital twin is it's a rendition of something real. It's instantiated in accordance and synchronized with something that's real. It allows you to understand digitally and ask questions of something real that you couldn't ask of the physical thing itself. And in the process of being synchronized with that physical thing, it can also allow you to simulate what that physical world thing would do in the future, given certain inputs. And against that backdrop, the digital twin is emerging. And this is like when we talk about things like training, when we talk about things like monitoring of heavy processes and assets and the like. This is where the digital twin comes in. And if you're a manufacturer today, I'm sure anyone who manufactures durable goods, aircraft, vehicles, whatever, they regard the digital twin as a huge computer-aided design, PLM, product lifecycle management topic. This is the new life cycle of the thing you're creating with your manufacturing process, how to track it from cradle to grave, and how to help your customer use it better and potentially predict things that your customer would view as valuable insights.
And Ricky, from your side,
Yeah,
digital twin fit?
Yeah, I mean, obviously, I think Kevin captured a few of the points. I'm going to add a little bit. So, again, I suppose I've seen the rise of digital twins, software models, and things like that. In the chip industry, we used to use a thing called CIMICs, which was the software modeling of what a chip is. So what is that? So I've got a software model of what the chip is. So it's a digital software model that then I give to a developer that develops an application that runs on the chip. So basically, I've got a software model of a physical piece of something that I then want to develop a software layer, an application that runs on, because I want to know if it works. So there's an example of a digital twin. Now, you can break this down into the industrial environment. Digital twins have existed for a long time. I mean, again, nothing new. It's kind of like we're just evolving them, really. We have a digital twin of a machine, a CNC machine, a milling machine, a something machine. So, we represent that in a digital model. And why do we want to represent that in a digital model? We want to see and understand how it's working. So, we use those digital twins then to create scenarios and things on them. For example, what happens if I put 5 tons of concrete on a conveyor belt? Is the conveyor belt going to break? Well, I've got the digital model of the thing. I can see how it reacts. One of the things I think that's important to add on from a digital twin. So a software model is one thing. How good is that software model? So, and that's really the piece that we look at a lot inside of Intel at the moment is how do we feed and make that software model of that physical item better? So what you're doing is you equip these machines with sensors and data that's coming off of the machines. Okay, so we get vision data, we get time series data, we're getting data from sensors across this. Those sensors are actually sending us information about what's going on in that physical environment. So what we can now do is say, well, we did a software model of this thing. We predicted that this would happen when we did this outcome. Now I can actually do that in the physical world and say, oh, actually, it was close, but it was a little bit out. So because now the sensor data can now drive us back and improve and link back into the digital twin. So now what we're doing is we've got a model where we create a software model, which is a digital representation of the system. We then feed it back with the data that's being fed off of the system based upon the outcomes that you were trying to drive, and using artificial intelligence to drive that kind of loop. So the digital twin is becoming more and more powerful. Now that's at a machine level. Now think about this as we step these things up. And again, I'm going to go back to what you said earlier, Kevin, which is, I can go off in Star Trek land, or I can come back to reality. So where we're at today is we try to keep the digital twins relatively contained to certain environments, but I can bring these things together now. I can create system level digital twins, which might be, let's say I have a cell inside a factory. You know, sometimes you have assembly, you have final assembly, you know, paint, things like that. So now I can do a system level digital twin where I can create processes that work together. Why do I want to do that? I want to look at the outcomes and drive efficiencies at a cell level, and then I can abstract it to a data level, to an entire factory level. And then I'm going to give you one thing as I start to see the world going forward. You know, sustainability and the carbon impact and energy is becoming very important. How can I now not only model what's going on inside my factory, but now I want to be able to bring data sources and actually look at supply chain. And I want to look at that holistically. I want to look at my supply chain, not only from my goods that are coming in, the quality of those goods and how they go to build it, but I want to look at where my energy is coming from. How does my energy get related to the efficiency of my factory? So again, start to think of these things as almost like Lego bricks. I have a Lego brick for digital twin, this one, this one. Now I want to bring these things together. Now I'll link this back maybe to the question around the metaverse and people. People are running those processes. They want to be connected to those processes because they understand them. So you've got to create an environment for them to actually connect the human part of bringing them into that environment so that they can better connect at the industrial level with those things as well. And I think that's that natural evolution. And I say, you know, I saw a point where we were getting very good at doing digital twins, very good at driving certain outcomes. And now what I'm finding is AI itself is becoming a problem. I got too much of it. It's like too much of a good thing. How do I manage that? I need people, because people bring in a different way of looking at it. They're not machines. They bring that connective. So I think that's where I see this idea of fusing these two things together becomes very important. So again, digital twins to me are phenomenal. They're great, wonderful. They're driving wonderful outcomes. And what we're seeing now is starting to see that next evolution of digital twins. And, you know, I mean, Lynn gave some examples about banking, things like that. Just think of the context. We often think very narrowly when we think of things, which is we think of the thing that we're doing in front of us. If you can now connect data, not only in your factory, to your customers, to your people running it, to your, you know, your supply chain managers, to your finance managers, everybody wants a digital twin of their area and they want to interact with that in a different way. So as I say, possibilities are out there, but let's keep it simple. You start with, we run these digital twins, we use AI, we bring it in, and we start building the foundations of what I think the industrial metaverse is going to offer in the next few years.
No, good points. And, you know, in my own opinion, you know, you've mentioned, we've been using digital twins. We didn't call them that, but we had digital representations of stuff. And whether it was a CAD model, yes, and we then built it, or we connected all, we put out IIoT and we connected everything, and we had a digital twin of what's happening right now. And then we had a VR training and we had something else. But in some ways they were, as you said, they were separate little silos. What we're starting to see now is people going, hang on a second now, I built it like this. This is how it's running. Can I overlay them? And if I may, there was a question here from Vikas, and I think you've answered it, is that we're talking about syncing the digital world and the real world. Well, what about, you know, what happens if it's raining? Do I need rain data? And correct me if I'm wrong, but of course you do. This is, you get data from all sources. That's where you get this digital twin. Physical meets real, right?
Yep, exactly. Lynn will probably quote on that, probably better than I will. Lynn, I'll let you answer that one because I think Penny's already in there.
Well, I'll give you a real world example where this plays out, right? Let's say I'm an aircraft manufacturer, so my customers do this, right? And I want to understand the effects of environment on the aircraft condition, right? So corrosion and other factors might be very important to me when it comes time to preventive maintenance schedules, and understanding, you know, the lifetime of an aircraft, where it sits. So the rain, in practice, people might or might not model that, but what they might model is they might apply to the digital twin for a particular instantiated aircraft its exposure to elements. And based on probably some average assumptions, want to put sensors and rain gauges out there, you could, but usually a digital twin is constructed and used with certain purposes in mind. And I think that's the difficulty. And I think one of the challenges we face is the semantic, I'll call it the semantic generalization of these digital models is quite a challenge because it may be insurmountable in some cases. In other words, I construct a digital twin. I have a concept of what questions I will ask of this digital twin, including futures, including current state of things, whatever it is I'm modeling. But to answer future questions that I don't anticipate may require some sort of semantic alignment between models that is very, very difficult to obtain ahead of time or enable. And I think this is one of the challenges we face. There's this concept of general purpose nature. And this is why people, by the way, are never going away, because people can do things like say, oh, well, that model did not take into account rain. And guess what? You know, this F-18 that's been deployed to Guam is getting rained on a whole lot more than the one that's been deployed to this region like Nebraska, right? And so that's why I think the people element continues to be highly relevant. Digital twins will never be perfect.
No, the questions are rolling in here, and there's a couple that are kind of teeing up the next topic. So I'm a bit of a geek, right? So I like the hardware piece, and we talk about all the future, the art of the possible, but we're going to need some different compute and graphics and comms, and we're going to need a different architecture, in my opinion. So a couple of questions that are kind of coming in on this, please. Phil Wolf has asked, can you talk about performance issues? Have we been running into any bottlenecks around IoT, digital twins? You know, is it becoming more demanding? We talk about cloud, and we talk about compute at the edge and whatever. And there's a second question here in terms of my question: where do you think the processor speeds are heading? You know, do we need more and more compute power, more AI, more rendering, more graphics? Explain, Ricky.
Well, let me just say yes. Now I'll expand on the answer to that question. Look, you know, I think the first question is, are there bottlenecks and things like that? Yes, this is a journey. You know, in the industrial environment, things don't change that fast. You know, for good reasons. You know, Lynn mentioned earlier that, you know, these are safe environments as well. These are factories and things like that. You know, there are technologies, there are standards. Security, operating standards, 61508 and things like that, 62443. The industry is regulated, you know, within it and an environment as well. And that doesn't matter whether it applies to a digital twin or even in a metaverse. You've got to make sure that what you're doing is understanding of the environments that you're working in, the people that you're working with, and the impact of those things as well. So we've got to make sure that we move our standards bodies and the way that we're bringing those things together, and understand that this isn't just a runaway train. It's got to be balanced with, you know, the people, the environments, and the things that we're doing. So that's one aspect of that. The other thing as well is that, and it's kind of interesting right now, and I talk about this a lot, maybe in slightly a different subject, which is, you know, you talked about the compute everywhere. Yeah, you're going to need graphics processors. You're going to need CPU processors. You're going to need compute, you know, in many areas. We talk in Intel a lot about what we call the intelligent edge compute, and I'm sure Lynn's very aware of that term. What do we really mean there? We're seeing a lot of compute move to the edge. Why are we doing that? We talk about this a lot as well, which is data. You know, so the data that's going to drive, whether it's digital twins or basically a collective immersive experience around digital models, there's a lot of data that's existing. That's got to get into systems and be accessed by systems, and it's got to be done relatively in what we would call real time. So, you know, connectivity and compute and connectivity, and the fusion of compute and connectivity is another area that's very important as well. If I've got islands of compute and I can't connect those compute together in a way that they can share that experience in real time. I mean, if you're in the metaverse, let's go think about it. I'm in the metaverse and I say, oh, I want to adjust that button, okay? and I'm pushing something in a digital, if it takes 26 minutes for it to hit the machine, as a stupid example, it doesn't work because it's not instant. So you need compute that sits at the edge. You need something that's going to process that, but you then collectively need to be able to send stuff up to the cloud. So I see this idea of what I call ubiquitous compute, fluid compute, I used to call it. You know, compute's going to exist everywhere. And what's powering the metaverse, what's powering these digital twins, the compute will sit near and where that data's got to be processed and looked at and run. As another part I would say is a bottleneck is machines that exist in the world today. They are speaking many different languages, hundreds and hundreds of languages, you know, in the industrial environment, but they don't all use a common language today. So when we're abstracting data and we have got to put that data in a way that we want to analyze that data, whether it's a digital twin or something else, if we're going to use it in a single line, fine. Okay, I've got a single line of data that comes from a machine. But if I'm going to mix it with other data sources, how do I bring that together and synchronize that across many different environments as well? Because if a machine is telling me something happened at 10:01 and 12 microseconds, and another machine is giving me data and it's 10:01, 12 microseconds, but the datas are not synced, I can drive a wrong outcome. So, you know, so technologies that we've been developing here in Intel, such as time-sensitive network, time-coordinated compute. So we need compute that exists. We need connectivity that's going to be real-time connectivity. Then we need the environment across the connectivity framework to bring these things together. And then we need to do that from an edge to cloud and an edge to edge. So, you know, to your question, Kevin, the technology is moving at a pace. To answer the other question, there are bottlenecks at the moment. We're working with a lot of the world's leading system suppliers as they evolve their technology to these new universal languages, things such as OPC-UA, which is really a unified language for connecting devices and machines, okay? So, and we're adapting those with those customers to bring the environments that needs to operate it. And then we need to work across the standards bodies and across the safety bodies to make sure that as they see that transformations coming through, they're also moving at the same pace. Because ultimately, what I care about most in the world is I want to drive a better outcome. When whatever I do, I want it to be better than what it was before. I don't want to go backwards. And I always say that, you know, so bringing those things together, making sure you align it with the people, the knowledge in the industry, bringing that pervasive compute across, making sure it's equipped right. I think that'll give you the foundations and the building blocks that are needed.
So,
No, good points. And Lynn, you know, to you, sir.
yeah, so just the good news for us is when we talk about metaverse, we're either spilling out or taking information in from humans. And we have seen, because one of the weaknesses to this synchronization topic, as Ricky's pointed out, is very complex. And if I'm trying to actually use software to control something, perfect synchronization is really nearly required here, right? Real time. The good news for people is the definition of real time for people. We are experiencing it right now, right? The people watching this can watch our lips move and synchronize in their brains the sound they're hearing with the facial expressions and the and our mouth movements, and pretty much piece together what would seem like a human conversation. So the good news is that the protocols that were developed for things like Zoom, for things like Teams, the codecs and the like, have done a great job of overcoming what is a true weakness, which is networking. The strength of TCP/IP networking is that it is best effort and highly robust without being perfectly synchronized. The downside is that it's not by nature perfectly synchronized. So what's happened is that because people are the consumer of these interactions with the metaverse, to keep up with the perceptions of people, hundreds of milliseconds is frequently good enough. And protocols have been developed that allow us to address things like, okay, well, that packet didn't make it in time, so drop it. You know what I mean? And let the human brain piece together the missing frames, which is exactly what Zoom and Teams and other things do. So I think the question is, there's certain types of digital twin updates that are synchronizations outside of what I would call the fundamental metaverse operations, which are the data path. The data and control path is what Ricky is talking about extensively there. The good news for the people side of it is that people's perceptions do not require the same perfection in the network. But there's no doubt that we do not have the technologies. I mean, we go in, we just tried to do fever detection in a factory in real time. And believe me, the networks and a lot of these operations environments are nowhere near capable, much less the messaging, things like what Ricky mentioned, like deterministic networking protocols. I mean, so this is an area that I think is going to require a lot of investment over the next 10 years.
Yeah, I agree.
No, great points.
Let me just add something to what Lynn mentioned there as well. I mean, it's a good point, and which is, and I kind of look at it as two things, which is, it's interesting how collectively technology which have been developed in different areas, we've mentioned Zoom and Teams and things like that. It's a collection of technologies that are coming together. 5G, which is the next evolution of mobile that everybody's very familiar with. They all, I've got a new phone. I got the new iPhone, and it's got ultra-wideband on it. Most people, I mean, it's super fast. But we're starting to see evolutions of technology in many different sectors all coming together. And they're bringing a benefit in that environment that we can then apply to where we're going in the future. So 5G to me was really about connecting things. It's not really about, I mean, honestly, I can't watch Netflix any faster. To Lynn's point, my brain can only concept when the lips are moving. So, but in the industrial world, when we talk about 5G, and now I can connect let's say I've got a high definition camera that's looking over an oil and gas facility, looking for a leak from a pipe. So it's looking for some sort of chemical. We want to know about that immediately. So now we've got the idea that we can connect something previously that was hard to get a twisted pair of wires somewhere. Now we can use 5G in those environments because we got new technologies in 5G, such as ultra-wideband, ultra-low latency. What are these things? They, to Lynn's point, they're deterministic add-ons to the technology. So the connectivity business is moving very fast. Us as people are a lot of driven, as I say, by COVID. Our tools and our environments for us working together are improving at an enormous rate. And then on the industrial side, we're starting to see, and Lynn, absolutely spot on. We are going for a process of working with the manufacturing on this kind of idea of what we would call software-defined manufacturing. What is that? It's changing the networking, it's changing the way that machines work in the factory because it drives better outcomes. Digital twins is one part of that. So these things are all coming together. So I've got the idea of the way people need to operate and work, the way connectivity is coming, and the way compute is coming. So it's a really interesting time. You're seeing lots of different environments collectively coming together to create those fundamental building blocks of where I think the metaverse allows us to go.
No, agreed. And I suppose I've been in the IT industry long enough that whenever we come up with some new cool, super duper technology, and whether it's the processing or the memory or the bandwidth on the motherboard or the communications, back to the people thing, we figure out ways, ooh, I can do this now. And then we create the next bottleneck, right? We just keep moving it around. And, I love the line, we talked about the cloud, and especially when it's real time for industrial, right? Real time is real time and synchronized, right? And you get the thing that, the speed of light isn't as fast as we thought it was. And then you can't put it on the cloud or whatever. And so I do think we're going to see, one of the best ones I've seen is if you are using VR, I host meetings in Altspace VR and stuff. You almost need as much upload bandwidth as you need download. And our telco connections are not built for 50-50, right? So anyway, look, we could be here all night, but we have about 15 minutes left, and there's kind of 3 topics I want to get to, but I'm going to jump in here with some of the questions on from thing. Samir asked, and I'm scanning here as well. I think it was, excuse me, I'm trying to find another name. But the questions, oh, it was Robin. What kind of skills do we need from the people for this going forward?
Go, Lynn, I'll let you go first because you.
Well, I mean, first and foremost, what we're trying to do is make good on the skills people have. So part of what the metaverse is about is enhancing the existing skills, and especially when there are specialists. And like Ricky said, go find a controls engineer. Just put an ad in the newspaper. Good luck. It's going to be a while, right? But if you know where they are and you want their expertise to be consumed far and wide, and maybe it's not a great example, they already can do their work remotely, right? But think about people who have expertise to diagnose a problem that requires them to be physically there. Those are the specialists whose skills don't need to change. They do need new skills for operating equipment that allows them to do remote diagnosis. That's the new skill. I mean, everybody will probably need some form of those new skills. I would say it's going to become a real issue, and I'll be curious if we'll ever punish people for getting headaches when they put on a VR headset and it causes them to basically not be able to do their job. Imagine if you're being prone to VR headaches caused you to become a surplus worker in the next generation. Those are probably some of the things we'll have to tackle. But the new skills are just simply, hopefully we make the metaverse for industrial easy enough to use that the skills required for using it are not that critical, and don't require huge investment, and that people are focused more on the skills they already have and enhancing those skills and getting deeper what they already know.
And I'm going to add one thing to Lynn, and again, I was related to my own interactions with my customers and the people that I talk to. One of the big challenges on a lot of these industrial customers is they can't get the new people coming into the industry. It's not very exciting saying, hey, your job is to pick up a spanner or something. And I'm not saying it's as basic as that, but it's hard to get people who want to become control engineers and they want to work in factory environments and things like that. I mean, it's not super exciting. So in a sense, I 100% agree with Lynn. I want to take the skills that are out there and I want to make it as they need to just, be able to resolve that without changing their skill set. But ultimately, I think what this represents as we start to move forward is how can these industrial companies make what they do more exciting to the younger generation? They want to be involved more in technology. So actually, in a sense, technology in this environment is going to help them. Because now if I'm a young engineer and, oh, you're telling me I'm going to get trained in a 3D environment using 3D simulated models and doing this, I don't know what comes after that. Those skills that those new engineers develop by using these new environments and tools will infinitely make them the next 3D control systems engineer of the future. So in a sense, I see technology here can be very helpful to a lot of customers because believe me, they struggle to get, everybody wants to go and work for, a cloud service provider, Google or Amazon or Microsoft or whatever, hey, because they're doing cool stuff, or I want to work for a games manufacturer. Well, if you created an environment where somebody can come in and do that well. And the other one I would say as well, and I go back to something I'm very passionate about, is the world of sustainability. We're all very aware of what's going on now. I want people, young people to be able to access technology and bring in their passion for understanding what we're doing here in terms of carbon reduction. They're going to come out with wonderful ideas that I'm not even thinking about right now. Because the environment that we're going to create, the data that we're going to give them access to, the way that they can consume it, I believe the possibility for those people to develop their own careers, their own futures in those environments, not only for the benefit of the companies that they work for, but also collectively the benefit they can get across the world for sustainability. I work a lot in the energy sector as well, and there's a good friend of mine who's out in France. I won't mention his name, but I remember him very well passionately telling me that he wanted to create an environment where he could open up the energy market to the world, because he hoped that that meant that young people coming in with the passion that they have, the new generation, that they could bring in that passion and that energy. So I think this environment is represents an opportunity as well in terms of the skills that they're going to get as they come into this environment.
Oh, great points. And, you know, Lynn, you mentioned that we talk about VR and AR headsets, and if you wear glasses, or some people don't like them and whatever. And again, I'm long enough in this world in terms of we judge things on how things look today, but I've seen contact lens based AR technology. Who knows what VR will look like in the future. And I personally, I don't believe that the metaverse has to be in VR, right? I think it's a mixed reality, real, whatever, right? But I just a very quick one on skills. I was at a metaverse conference recently, and someone was on about, well, what are the new skills and whatever. Now, I'm a gamer. I play too much Fortnite, right? I'm a big kid. But someone said, look at Fortnite, look at Minecraft, look at Roblox. All these kids, they're not just playing the game and consuming game, they're creating their own virtual worlds.
Yeah.
And what are they doing? They're doing drag and drop. So it's a low code, no code type design environment. They're all artists. Because someone said, well, where are we going to get all the people to create all these 3D models? We need more artists. And I was in an industrial conference, someone said, we don't have any artists. And they said, you will have. And that's how you get the cool kids.
Yes.
Yeah. That's a great point. Yeah.
You know, let's see what thing. Now, the clock is against us. We've got about 9 minutes. Yeah. Now, again, I live in a bit of a world where the art of the possible, and, you know, the endless possibilities. But I have yet to meet a company who's kind of going, Kev, that's a great idea. We're going to go all in, and here's billions of dollars, and we're not sure what we're doing, but we're going to get there. Most companies kind of go, no, we need to fix a problem we have today, and we need to make it profitable and whatever. So if I may, I suppose a double-barreled question to as we kind of wrap up. What will be the business and benefits, and where do you start? So if Lynn, where do you advise the folks you work with day in, day out? They go, oh, this is wonderful, but where do I start?
Yeah, you know, and I think the place to start is thinking about your processes. Most of my customers know roughly where their bottlenecks are, but they have no way of modeling the interaction between certain key processes today in order to remove those bottlenecks or understand them better. And so one place to start is think about those processes, like you've modeled in your mind, you know, what your throughput is for an hour, your best throughput for a day, your best throughput for a year. What's the difference between those three numbers for this particular process? That's probably a candidate for building a digital twin. Now, the tools obviously are still very diverse for doing that. But I would say, if you think about, if you want to hit something where you know you're going to get a return, it's think about the throughput differences and whether or not you've got a model of that process. That would be a candidate for a digital twin. And I would say anywhere you have very scarce labor related to physical operations, that's where, if you wanted to experiment with, we call it XR, X reality, it's AR, VR, just visual remote guidance. We have over 100 customers for visual remote guidance that we have today. I'm not saying that to sell anybody on it, but just to let you know that there is a ubiquitous need for remote see what I see for people who are experts, and think about where you have the most critical shortage of those types of skills, that genre of skills. Great opportunity to think about bringing XR into your environment and creating an efficiency you don't have today.
And I'll add in, Kevin, to Lynn's. I think that Lynn was a great answer. I mean, first thing, as I say, is, you know, I actually think in the industrial world that I'm in, people have started. They've been doing this a long time. I think we've emphasized that already. So, but, you know, sometimes we think about these concepts and we think it's very hard for, I mean, the world of industrial consists of, you know, a lot of very large customers. You know, I think of the auto manufacturers, you know, they're huge discrete manufacturers. But actually the world of manufacturing is huge. It exists everywhere. Small, medium businesses are really the backbone of the manufacturing industry. So I'm going to pick up on what Lynn said. I think a lot of people are already doing it. I think start to look in your own environment where your own challenges are, you know, and that's going to be very different depending on where you are in the world. You know, it could be a labor challenge. It could be a production quality challenge. It could be a competitive challenge or a cost challenge. So systems are out there and they're available today, not only around digital twins, but bring in data, start using data, get familiar with the concept of data. We do a lot of work at the moment around machine vision. Machine vision being used to do so many different things. And again, I always say machine vision is relatively straightforward. You're bringing in something that is an imaging system, a camera, if you want to call it, that is doing something that's generating data. The good news about that is it's not necessarily intrinsic to the system that you have today, which you might find trouble getting access to that data for whatever reason. You know, might not understand getting how do you get the data off, you haven't got the access that you need, you know, with your system supplier. But if you're using machine vision, you can start somewhere simple, and that can be very, very simple. It can be just looking at, hey, I'm looking at items that are being packed in a box, and I'm making sure the label's up the right way. You know, it's a very simple use case that, you know, but ultimately it has an impact, because if the label is packed wrong, it's a defect, and the defect means it's going to come back to you, which means there's a cost to that. So I would say, I think we've already started to see, we're seeing a lot of companies that are already moving to digital twins. Start to understand data and your journey on that path. Look at the challenges that you've got and try and narrow it down to something that's very important to you, particularly at this time right now. You know, I mean, I'm not anticipating that everybody builds something, you know, that's hugely glorified by what we think the metaverse is going to offer. This is about understanding what your challenges are over the next 6 to 12 months, and start working with your, you know, your local system suppliers within your environment. And feel free to reach out to Intel, I'm sure HP as well. And we can put you in a direction where you can get a lot of information about your journey towards the metaverse, but much more important, your journey towards understanding data and starting to understand artificial intelligence. Once you start to build those bedrocks in your business, you'll be really well set up for where you want to go next.
No, thank you, Ricky, and thank you, Lynn. You know, when we started out with Lucy, and probably 18 months ago, I was saying, we got to keep an eye on this metaverse thingy. And my point was that I don't know what it's going to be. I don't know what we're going to call it. But if you look at a lot of the foundational building blocks in industry and in the energy industry, where I spend a lot of my time, I was going, we're doing bits of this already.
Yes.
VR, AR, digital twins, IoT, embedded, compute at the edge, you know, whatever, right? But we're and as you've articulated excellently in the last hour, it's kind of joining those dots. And when people say to me, oh, Kev, this is great, how do we get there? My first question is, what data do you have? Do you trust it? Yeah. Is it good data? And like, that's $1 billion question as well. But I do believe that people look at this and they go, it's aspirational, but yet what they're doing today, whether they're small, medium business, or they're the big guys like you folks, the people are on a journey, and you know, the next wave of digitalization isn't slowing down. Neither is innovation and technology, right? So it's just joining those dots. Ricky, Lynn, come here. Thank you so much for joining us. We're right at the top of the hour, folks. I apologize. We've got about 10 unanswered questions. I know that Lucian and the team will be following up with Ricky and Lynn. There's a lot of great questions there. You know, we could probably keep talking here for the next 24 hours and we'd still be only scraping the surface. So come here. Thank you so much. Ricky, Lynn, thank you, sirs.
Thank you, Kevin. Thanks to the audience for listening.